formerly of a company called Meroxa that helped create this tool. So I'm currently fun employed before I start my next gig. So enjoying a little bit of a much needed break in sabbatical. But first time here in Utah, very excited to be here. So thank you for the organizers for allowing me to be here. And I'm going to talk a little bit about Conduit. So it is a real-time tool built top to bottom and Go for streaming data. So I'll try to, I know we only have 30 minutes, so I'll try to move through the slides pretty quickly so we can look at a little bit of like a code and actually look at a pipeline. So real-time data, like data is all around us, right? And we're constantly generated, whether it's us as individuals or as larger corporations or companies. And it's coming faster than ever. So a lot of times we need to be able to operationalize that data, right? So as it's coming faster and faster, how can we get better and better insights out of it quicker and quicker? So that's what we try to accomplish with Conduit. So with traditional ETL models, mostly done in a batch format, it has its place, right? Certain things you don't necessarily need in real time, that you can kind of, batch it, process it with it, and as it comes in, or whether it's hourly, daily, monthly, whatever. You don't always need real-time data. But in some use cases, you do, right? But with the batch method, sometimes you can run into operational overhead, right? So dealing with job schedules, workflow managers, dealing with just the overall architecture can sometimes be laborious. But it also then can lead to stale insights. So if you're doing something where you're generating, constant data, where you think about whether it's stock market data, I'm a big sports guy, where you're trying to do like sports analytics, like doing like play-by-play data and doing like win probability. That data's coming in constantly and coming in fast. So you need to be able to capture that data in real time and be able to process it. So, oh, sorry. So you need to be able to operationalize that data quickly. And sometimes batch just doesn't cut it. So how can we start to, think about doing this in real time while also trying to reduce the operational overhead? So this is where Conduit comes in. So this is the impetus behind building this tool. So it is a lightweight open source Go-based streaming tool. It compiles out to a single binary, so you can deploy it even on edge devices. And you simply just need to define a source and a destination using a YAML file, and you can start to get real-time streaming data. So we're gonna, again, I know I'm moving kind of quickly, but we're gonna kind of go through and look at a little bit of the internals of like using Go, why they allow Conduit to be, and then look at some examples. So why use Conduit? So some of the things we already talked about, right? Where it's ideal for developers who are trying to build real-time data streaming solutions without a ton of overhead. So you can look at applications where it's like, replicating the database, so moving data from one database to another, or just any type of like event-driven architecture. Conduit is a fairly good choice for that. So it provides it comes with certain connectors already built in, but we also provided a SDK where you can then build it, custom connectors for your own data sources. So the value to different stakeholders. So we talked a little bit already the value of like for engineers, so to be able to quickly build data pipelines, but you can think about just from the business aspect as well. So you can have faster time to market to try to get operational data insights. With the DevOps team, it combines down to a single binary, so hopefully you can have easier deployments and maintenance with that. And then with product managers, you can enable real-time feature and user experiences. So a brief look at at Conduit's architecture. So Go's internals around concurrency is part of what allowed Conduit to come to life. So using goroutines is like part of the bread and butter to Conduit's internals. And admittedly, I'll say before I came to Meroxa, I had never used Go before. So I basically learned Go on the fly, and it was a very, very interesting experience, and I really enjoy using it now. By no means an expert, but I was able to learn a lot, and in particular around like its concurrency model. So it uses the goroutine, so the really, really lightweight concurrency, and then to communicate between the goroutines, we have channels. So this allowed Conduit to be able to really operate very efficiently and operate at scale. So to talk a little bit about Conduit's plugin architecture. As I mentioned, the architecture has some built-in plugins, so some common data sources that you may deal with. So Kafka, Postgres, S3, those are included, batteries included out the box whenever you download the Conduit binary. But we also have the SDK where you can then go and write your own connectors. So we'll have some examples as we move forward in the slides of some connectors that I wrote for different projects that I worked on. That we didn't support natively, but then we were able to roll those out. And I think the list is currently over like 100 supported data sources out there, and more constantly being added. So I have there written that you can write them in any language. We pretty much always defaulted to writing the connectors in Go. It was just the easiest thing. All of our rest of our data stack was primary, or stack with Conduit was primarily written in Go, whether it was using the connectors. And I actually haven't mentioned the processors yet either. So the connectors can be both source and destination connectors, but also our processors. We have the processor SDK written in Go as well, which can actually operate and transform data in real time as it's moving through the data pipeline. So I have a couple links here, and I'll be sure to share those out as well, as far as the Conduit SDK for being able to go and look that up. We also have templates as well that you can quickly clone for building connectors or processors. So just around the push model. So as you build the connector, you can connect to whatever data source you have there. And it's going to, depending on how you build your connector, it's going to constantly, whether it's going to be polling or just connecting to like a WebSocket or something like that. Anytime that source emits a new record, it will then come through the pipeline. If you have a processor there, it can optionally process that data and then move it to 1 to n number of destinations. So we also built around Conduit like some observability, so that you can actually hook in and look at the state of the pipeline and see the data as it's flowing through. Sorry, part that got cut off. Again, I know I'm blowing through this pretty quickly. And also one of the things we really wanted to try to, which I really appreciated about Conduit, like one, it is open source, so it's out there for anybody to use and contribute to. Also, really wanted to have a clean developer experience, because if there's too much friction in using it, especially an open source product, no one's going to use it, right? So we really wanted to value the developer experience of being able to quickly create pipelines, stand them up, and get value out of them. So as I mentioned, it compiles down to a single binary, has a clean CLI, and a single command of just saying Conduit run to start to spin up your pipelines. So the configuration files are written in YAML, which we'll see an example of that momentarily. And and there's some niceties around it, having both REST and a REST API and gRPC to be able to connect to your pipelines for programmatic control. So just a little bit about the something's cut off. Okay, I'll scroll back. Around the performance and reliability. So again, we designed it with scalability in mind, also with reliability in mind. So each record has an acknowledgement as it comes through the pipeline to try to only have each record delivered once. And then we also have fault tolerance built in. So we have like a dead letter queue for any times like a record needs to be dropped or retried or something like that. And one of the nice things too that we get basically out the box just with Go's concurrency model is natural back pressure management. So anytime like those channels start to block, the buffers fill, it queues them up until they're processed. And I know this may be hard to read, but there was also another open source tool called Benchy that we wrote and used to get some benchmarks. And the throughput, I think at our highest, or one of the things that we measured was like 569,000 messages per second. So these are a couple of use cases, again, that used in production. Some of these I worked on personally. One was the hotels network. So being able to integrate their sales and support. So they wanted a streamline of data from moving from Salesforce to Red Panda. So we were able to build more custom solutions for them. One that I worked on personally was a healthcare project where, as we talked about, in batch, sometimes it works and sometimes it doesn't. In this case, there was a healthcare provider who was getting data that was just sitting on an SFTP server, and then it wasn't being moved over into like a patient came and saw their PCP, and that data needed to go out to a specialist. It could be anywhere from 2 to 5 days before that batch job ran to move that data out to those specialists. So we ended up writing a custom connector and processor to process HL7 data, which is a healthcare format, to move that data in real time. So as soon as the data hit the server, anytime if it needed to go out to any other provider, it could happen immediately. Another one I personally worked on was in a military space, where this was dealing with AIS data, so maritime data. So AIS stands for Automated Identification System. So this was getting real-time data off of ships that was in transit. So being able to, again, it's one of those things if you were doing in a batch thing, and it's not necessarily as useful, right? Because if they're constantly moving, they could change course due to any number of factors. So in this case, we were getting the real-time data from a GraphQL API, and then pushing that to the Unified Data Library, which is a data lake managed by the Space Force. And then lastly, another example is Spill. So again, we can see this was used across several different type of industries and use cases. So Spill is a social media app similar to like X or Blue Sky or something like that. And they were tracking real-time user engagement and moving data from DynamoDB to Postgres. So we were able to use Conduit to manage that as well. So I know I've talked a lot, went very quickly over these slides. So now we can actually jump into a code editor and actually see Conduit in action. Is that large enough? Do I need to make the text? All right, I will make the text larger.
That's good.
Switching to light mode also makes it much more readable in projection.
Okay.
But then you'd have to be in light.
I was trying to find the settings if I can do that quickly. I don't know where that is.
Yeah,
Search.
but it's yeah.
Don't worry about it.
All right, cool.
A setting for that.
Not that important, just slightly better.
Gotcha. Okay, so this is a very contrived example. Let me put that out there up front, where we're going to look at based on an anomaly detection pipeline. So what I first have here is just a very simple, fast API server that's just generating just some mock kind of like data of things coming on that's going to basically going to flag like security issues or something. So very contrived. Just a little simple example to move data, just to give us an endpoint to source some data from. So then I have just a basic, just a Postgres database running here in Docker. This is where we're gonna push the data to. And then as we start to get into actually using Conduit, let me close this to move that and get more space. This is a YAML file to define a Conduit pipeline. So in this case, we have the pipeline ID, which is anomaly detection, give it a status, and then we can start to define the connectors. So in this case, I'm defining a source connector that's using the HTTP source just to connect to that Postgres database. I mean, not the Postgres, the fast API server that I have running. And then from there, I'm defining 2 destinations. The 2 destinations are actually going to the same destination. They're both going to the Postgres database, but they're going to 2 different tables. So one, it's almost a facsimile of like a medallion pattern, where in this case, we're moving the raw data to one table, and then we're going to do some transformations on the data and move that to a separate table. So to be able to keep the raw data, but then also some operationalized data. So in this case, the first one, we are moving that to the raw security table. So this is just going to take straight the data that we're getting, that we're sourcing from that fast API server and moving it wholesale, no changes for the most part. Well, I'm doing a slight change where I'm just generating a random ID, but moving that data over raw to a table. The second destination connector we're using, again, going to that same database, but a different table. And what we're using is one of our AI processors. So we're using our OpenAI text gen processor. So what that is, I have an AI API key, and I have a system prompt that, as this data is flowing through the pipeline, I'll be able to send that off to OpenAI, do some processing on it, send that, and whatever the API responds back to, get that, and then put that into the database in a given format. So in the system prompt, we tell like OpenAI, we want the format, the data in this particular format. And in this case, we're just doing a simple analysis on, say, if it triggered and this was flagged as some type of anomaly, say, hey, what are some remediation steps that we could potentially do with this? So again, a bit of a contrived example, but just showing how we can, one, move data in its raw form and then move data that's been processed in flight. And then also define this dead letter queue for any type of errors that happen along the way in the data processing. So I'm gonna mic down just so I can type with both hands. We can simply say Conduit run. But first, I actually show I have the database running in dbeaver, and we can see the database truncated tables. I truncated the tables, so there's nothing there right now. So if we do Conduit run, again, this is a single binary that I'm on a Mac, so you can install it via Homebrew. If we go here, this is first the raw table. So we can start to see data coming in. And again, like I said, very contrived data in this case, where we can just see like, hey, this was flagged as a security threat, the threat type, threat level, associated CVE, so on and so forth. But if we go to the AI analyzed data, we can start to see a little bit more insight, where, because this data was passed along and processed by LLM before we put into the database, and you can say, okay, what are the affected systems? What's the potential damage? What are the immediate actions that we should do to try to respond to this incident? So if you have like a run book or something like that, hey, what should we do? Should we conduct a forensic analysis, so on and so forth? And then we also have this mitigation strategy. So again, you may not necessarily do this because you may not want to say anything like your security issues to a LLM. That probably wouldn't be the best idea. But like I said, this is just a contrived example to show how quickly you can create a data pipeline and also get production or like operational insights out of it. So again, I know I'm moving very quickly because I know we only have 30 minutes. So and then last, I just want to talk about, again, this is open source. So out there on GitHub under the Apache license, if it piques your interest, feel free to go out there, toy with it, play around, contribute. We would love to have contributors. Again, handling open source projects is a labor of love. So hopefully this could be of value to the community out there. We know, like I said, we personally love Go. Go has been awesome to work with. It's been a really fun journey for me to learn and continue to learn about Go. It's one of the reasons I was really happy to be able to come here. But yeah, it does some cool things now, but it always can be better. So key takeaways we wanted to say is just we try to strive for simplicity without compromise. So still being able to create powerful data pipelines, but without the overhead of like dealing with the JVM or no offense to Java people out there, but like anything that's all other overhead that could come with some of the other tools that's already out there in the market, and then just goals, just the architecture and concurrency model of Go really allowed Conduit to be what it is and flourish. And we wanted to try to put a tool out there that would allow any and everyone to be able to leverage real-time data. And that's pretty much all I have. Yeah, happy to answer any questions if to the best of my ability.
What's the overhead for writing a custom processor or data source? Like, what kind of implementation? What does it take to do that?
Yeah, so again, we have an SDK for that, and we also provided like a template that you can clone to kind of get you really started. It gets you most of the way there. There's a couple patterns that we kind of developed along the way. Like one was like an iterative pattern that we put documentation out there around. We started toying around at one point with like code generation, trying to, where you can just prompt it and it generate a connector for you. Didn't really get to the point where we wanted it to. But there's again, all the connectors out there are open source, so you can kind of look and model and pattern off of those. But the definitely recommended way is to go and clone a template because it gives you really all the methods that you need to define. And yeah.
So it's like implementing an interface or a gRPC server or something like that?
Mostly just implementing an interface.
Okay, that's easy. You have to build that into the Conduit binary, or will it execute it for you?
Yes, you don't have to build it into the binary. So whenever you're running it, it's gonna, and you can, there's flags for these, but by default, it's gonna look for a couple different directories. It's gonna, whenever you're running it, it's gonna look for like a connectors directory. So if you build like a custom connector, you just drop it in there, and it'll look and load it at runtime. Same thing for processors. You drop those into that processor directory, but you also, with the flag, I think it's like -- connectors path or something like that. So if it's not in a directory called connectors, you can define where it is, and it'll detect those at runtime.
If you know the answer, how does this compare and contrast to Benthos?
I don't have a good answer for it. Like, I'm not as familiar with Benthos, so I can't really, I wouldn't be able to give a good answer that I'm confident in.
Thanks.
Yes.
One of the slides mentioned a stream inspector over WebSockets.
Could you repeat? I'm sorry.
One of your slides mentioned you could inspect the pipeline over WebSockets. I was curious if you could show that, or.
Oh shoot. I can. I don't remember how to do it off the top of my head. Put me on the spot. Let's see. Let's see if I can figure it out. If I can't figure it out right now, which highly unlikely, I have to go and like comb through the docs myself. I'll give it a try. But if not, I can try to somehow get that information to you later.
Yeah. Thank you.
Oh, I saw another hand.
Thank you.